Hello everyone and welcome back. So now we're going to go through a second example. Now what's example 2.2 going to say? Well, first off, we have two forces acting on this point right here. And let's see, Fx and 4,000 pounds. 4,000 pounds looks like it's going in the positive y direction, and x is going in the x direction, obviously. And that object, because of these two, is pulled along a line defined by a 40-degree angle with the y-axis. So it says determine the required force Fx and find the magnitude of the resultant of the two forces. Okay. This might seem hard because you haven't done this before, at least not much, but it's not going to be that bad. Now this right here, this is just a triangle. We just have to draw it. We're looking at like a box right now, but we can rewrite this as a triangle because we're trying to figure out, well, one, what is this? And two, what is this guy right here? So let's rewrite it. Let's rewrite it as a triangle real quick. And I'll go to the next page where I actually show you how all this is done. Okay, so I'm going to redraw it as a triangle. This is Fx here. This is 4,000 here. This is a line right here, which we're going to call R. And this is 40 degrees. And what you see instantly is, wait a second, it's just a triangle. There's nothing crazy about this at all. And all I have to do is use my, cosine of theta, sine of theta, to solve for everything. I'll be done. So let's see that done on the next page. First, we're going to use our trig functions to solve for r. Cosine of theta is equal to adjacent over hypotenuse. So I know the adjacent one right here. I don't know the hypotenuse, and so I need to solve. So I plug it in and I get that r is equal to 4,000 pounds over cosine of 40. As a note, your resultant here for these kind of right triangle problems, it should be bigger than either of the components. So if this is gotten smaller, we know we've done something wrong. So 5,220 pounds, we're good. Well, now that I know that, that's all taken care of, I can find out what f of x is. All we're going to do here is use our trig functions once again. Now, if I want to, I can redraw f of x over here, and I would use sine of theta. Or if I want to, I can just say, well, this is 90 degrees. And so if I want to figure out what this angle is, well, that would be 90 minus 40, which is simply equal to 50 degrees. So I know what the hypotenuse is, 5,220. I don't know what the adjacent side is. I know what the angle is. It's just 90 minus 40 degrees because we always have that right angle. And so we plug everything in and we get 3,360 pounds. That's just that component right there. We're just using our trig functions. That's all we have to do to solve this problem. And we're done. With that, we have the answer. It's 3,360 pounds. And it once again makes sense because it should be smaller than our 5,220 pounds. And if you really wanted to check this, since this is a right triangle, it's only got two components, we can just do this. 4,000 squared plus 3,360 squared. And that should equal 5,220, or at least very close to it. And it does. That was just Pythagorean theorem right there to use it. So you're going to need to master those trig functions. I strongly suggest that you practice. I gave you a trig function, a component practice sheet and a trig function or right triangle practice sheet. You should use those. Use those to help yourself out. And if you look at this right here, you see adjacent over hypotenuse. Well, just make sure that you know the names. That one was adjacent because it's right next to the angle. Which one is the angle touching? The angle touches this line, it's adjacent to it. If you're trying to figure out which side is the opposite, we'll just draw a triangle and your angle is at the point. You can just rearrange it however you want to. And then whichever side is the base, that is my opposite side. Okay? It's the base of the triangle in this particular situation. Okay, with that, we have solved this problem, and next time we'll do another one. So I hope this helped you, and I'll see you all next time. Bye-bye.